Hello everyone. In this video, we're going to discuss the fundamental theorem of calculus. Now, the fundamental theorem of calculus, or I will later on refer to as FTC, is normally divided into two parts. The fundamental theorem of calculus part 1, or FTC 1, states that if we have a continuous function f on the closed interval ab, then the derivative of f of t of the integral of f of t dt from a to x is equal to f of x for a less than or equal to x less than or equal to b. So ano ba ibig sabihin nito? Ang ibig sabihin lang nito is that if we're taking the derivative of the integral, we're going to end up with the original function. So if you would recall, this part here is the differentiation symbol, or it's one of the ways to write the derivative. Tapos ito, as we have previously discussed, is the antiderivative or the integral sign. Okay? So let's start by applying this theorem for some examples. First one, find the derivative of f of x equal to the integral of 11t squared over t to the fourth plus 1 dt from 1 to x. Okay, so technically, given tayo ng function f, we want to find f prime of x. So we simply take the derivative of this one. Using FTC1, if we write it this way, in a way, we can think of it na magka-cancel out itong parts na to. Tapos, technically, ang mangyayari is that we're going to end up with f of t. So, ito yung f of t. But we want f of x. So, we can simply do that by changing the variable. So, we have 11x squared over x to the fourth plus 1. Okay? So, sana na-realize nyo na technically, ang nangyayari lang dito is that yung variable, in this case, t, ay pinapalitan natin ng x. And that is simply because derivative or differentiation and anti-differentiation are inverse processes. Okay, next example. Find the derivative of this one. So, ano lang ang pinagkaiba nito from the previous example? Pinagpalit lang natin yung bounds or yung limits. Now, in FTC1, it is important na yung variable ay nasa upper limit. So, what do? We apply one of the properties of integrals or definite integrals. That is, technically, this is equal to the negative of the integral from 1 to x ng 11t squared over t to the fourth plus 1 dt. And then, from here, we can approach it the same way as the previous example. That is simply, we take the derivative of this one. So f prime of x, this is t over dx of negative of the integral from 1 to x of 11t squared over t to the 4th plus 1 dt. Okay, so similar to our first example, ang mangyayari lang dito ay yung t, papalitan natin ng x. But take note, may negative tayo sa simula. So, negative 11x squared over x to the 4th plus 1. Alright, so sana wala pang questions at this point. Or if there are, you can pause the video and replay this example. Okay, let's proceed to a more complicated one. So, medyo nag-evolve na yung examples natin. In this case, we want to find the derivative of f of x equal to the integral from 1 to square root of x of 11t squared over t to the 4th plus 1 dt. Okay, technically, wala namang problema dun sa position ng bounds. Yung variable nasa taas, then constant is the lower bound or the lower limit. Pero, ang problema natin ngayon is that yung bound sa taas ay square root of x instead of x. Okay, so if we just want yung kanina, ang nakuha natin is f prime of x equal to 11x squared over x to the 4th plus 1. Tama? But this time, hindi x yung input variable natin. It's actually square root of x. So how do we do that? If we want square root of x, same with function evaluation, ang mangyayari ay lahat ng x, papalitan natin ng square root of x. So we have square root of x, and squared to the 4. But notice na we can actually treat this as a composition of functions. And recall how we do that before. Ang ginagawa natin dati, kapag ganito yung form, we actually apply the chain rule. So after evaluating the function at square root of x, we also have to multiply this by the derivative of square root of x. Okay? So again, this is because of the chain rule. Okay, so having done that, we will end up with f prime of square root of x equal to square root of x squared is just x, and then square root of x to the 4th will become x squared. Tapos, i-multiply pa natin yan sa derivative ng square root of x, which in turn would be 1 over 2 square root of x. Okay? Last is to simplify. Note na may x tayo dito, then may square root of x, so we can actually simplify this. This would be square root of x now. So the final answer would be f prime of square root of x is 11 square root of x all over 2 times quantity x squared plus 1. Okay? Okay, for the last example for FTC1 is that yung dalawang bounds or dalawang limits, the upper and the lower limits, are both variables. So find the derivative of f of x equal to the integral from x to x squared of e raised to t to the fourth dt. Okay, so our closed interval here would be a closed interval x to x squared. Note na kailangan yung lower limit natin ay constant. Okay? So what we do is we're going to introduce a constant. So let c be in this closed interval x to x squared. Then, using one of the properties of integral, hindi pa f prime, f of x lang, we can rewrite this as the integral from x to c ng e raised to t to the fourth dt plus the integral from c to x squared ng e raised to t to the fourth dt. Okay, and then, note na yung constant natin ay nasa taas for the first part. So, we again apply the a property of integrals na pag papalitin natin. And then the second part is still the same. Okay, this part here is quite straightforward kasi x lang yung upper limit. Yung t, papalitan lang natin ng x, but note na may negative dito. So, this one would become, so f prime of x na to. F prime of x would become e raised to x to the fourth. Pinalitan lang natin yung t ng x, pero may negative. Okay? And then, the second part would be, note na x squared yung upper limit natin. So, plus e times, instead of x, magiging x squared times the derivative with respect to x of x squared. Okay? Then, simplify. When simplified, this will be negative e raised to x to the fourth plus 2x e raised to x to the 8th. This is our answer. Okay, so that is for FTC 1. Now, FTC 2, this gives us a way to solve for the area under a curve easily without having to use the concept of Riemann sums. Okay, FTC part 2. So if we have a continuous function f on a closed interval AB, then the definite integral from a to b ng f of x dx is equal to capital F of b minus capital F of a, where capital F of x is any antiderivative of f of x, or that means capital F prime of x is equal to f of x. Okay, so note na previously, this part here is equal to the limit as n approaches infinity of the sum of this one, or using the concept of Riemann sums. But this time around, we're just going to use FTC2. So, para mas madali na rin ma-solve yung area under a curve. So, examples, kung naalala nyo, ito rin yung ilan sa mga sinolve natin before. So, if we have the integral from 0 to 4 ng x dx, we can simply use FTC2. We identify A as 0 and B as 4. Then, pwede lang tayo mag-power rule dito. So, x squared over 2. We evaluate this from 0 to 4. This will be the notation used. This one is 16 over 2 minus 0 or 8. Okay? Now you can check the previous video or one of the previous videos and see na ganito rin yung nakuha na natin. We used two methods back then. Yung graphical way na triangle siya, tapos we solve for the area of the triangle, and the other one is by using Riemann sums. Okay, number 2. Similarly, this is x squared over 2, but this time we evaluate it from 1 to 4. So this would be 16 over 2 minus 1 half or 15 over 2. So, di ba? Madali lang siya. Number 3. Again, this is just, or we can just use the power rule. So, x cubed over 3 plus x squared over 2 plus x. We evaluate this from 0 to 1. This would be 1/3 plus 1/2 plus 1 minus, well, lahat sila may x, so minus 0 lang. This one would still be 11 over 6. So, itong first 3 na sinolve natin using FTC2, pwede nyo siyang balikan dun sa video natin for the definite integral as area under a curve. And you can see or you can verify na ito yung mga nakuha nating sagot. Number 4, this one is a trigonometric function. So, tatandaan lang natin yung theorem natin dito. This is equal to sine x. We evaluate this from 0 to pi over 4. This is sine pi over 4 minus sine 0. Sine pi over 4 is square root of 2 over 2. Sine 0 is 0. So we have square root of 2 over 2. And lastly, 2 over square root of x minus x dx. So we again apply the power rule. This one is technically 2 times 2 times x raised to negative 1/2 minus x dx. So using the power rule, this is 4x raised to 1/2 minus x squared over 2 evaluated from 4 to 5. If we perform this correctly, this is 4 square root of 5 minus 25 over 2 minus, this would be 4 times square root of 4, that is 8, minus 16 over 2, that is also 8. So, minus 0 lang siya. So, final answer would be 4 square root of 5 minus 25 over 2. Okay, so in summary, FTC1 states that the derivative of the integral of a function is the function itself, and FTC2 gives us a way to solve for the area under a curve easier or without having to use the concept of Riemann sums.